This is a video on how we do a bit more hard factorising. So I'm just going to go through some examples, but first let's talk about a refresh on what's a factor. It's all about factorising. So factors are just numbers that we multiply together to get another number. So for example, if we were doing the factors of 6, so factors of 6, there would be 3 and 2. We do 3 times 2 and we get 6. A common factor is something that a factor that is common to 2 or more numbers. So if you've got, say, let's do 8 and 4. Alright, so what are the factors of 8? Well, 2 numbers that multiply together to get 8 are 2 and 4, and 2 numbers that multiply together to get 4 are 4 and 1. So the common factor, of course, would be 4 in this case, a factor that is common to 2 or more numbers. So that's just a definition for you and a few things on factors. Now, let's do some examples. So, first example, we've got AX plus BX divided by AY plus BY. Okay, the first thing I want you to make sure you do is that when you have variables, just think of them as numbers. That's all they are. They are just numbers. They're called variables because they can take any value, but they're just numbers. Alright, they're representing a number. So don't treat them any differently than you would numbers. Okay? So, if we had this, instead of AX, we're going to be, and this might help some of you, instead of writing it as variables, you might want to put a number. So you want to put A times 2 plus B times 2 all over A times 3 plus B times 3. Now if I said, okay, find the common factor, well, the common factor, it's a number that is multiplied by, a factor is a number that is multiplied by another number. So 2 times A plus B times 2, obviously 2 is the common factor. So you put 2, bring 2 outside the front, and you go 2 outside of A plus B. And then down the bottom, what's the number that's common? Well, 3 is common, so you do 3 outside of A plus B. Now if you're going, why do you do that? Well, when you multiply this through, okay, this actually means 2 times A plus 2 times B. And you divide that by 3 times A plus 3 times B. Alright? So that's that bit. That's how you'd factorise that. But we don't want to factorise that. We want to factorise the one with x's in it. So let's have a look at how we do that. Alright, so what is the number that is common to both here? Well, in the top one. What's the number that's common to both? X. X is in this term. A term is something that is separated by a order of operation, a plus or minus sign specifically. So x is in this term and x is in this term. So we bring x out the front and we do x times A plus B divided by, and then we've got y in here and y in here. It is the factor that is common to both terms, so we go y outside of A plus B. Alright, so we've got x outside of A plus B outside of divided by y outside of A plus B. Now again, think of it like numbers. If we had x times 2 over y times 2, what would you be able to do? You'd be able to cancel, yeah? You'd just be able to get rid of the 2's. Well, it's exactly the same thing. A plus B is just a number, and the x outside the brackets means x times A plus B. So we can just cancel, and we will end up with xy. So that's one example. Okay, please write down some examples as you're going along because they're going to help a lot with your puzzle that's coming up. Alright, what about if we have something that looks a little bit more tricky? So example number 2. What about if we have 7z take 14, I can't write, plus 21x plus 28y. Now this is a bit trickier, alright? And here, it's really good to think about your multiples. So what are multiples of 7? For example, if you wrote them out, there'd be 7, 14, 21, 28, alright? If you're not sure, and you look at a problem like this and go, I really don't know what I can factorise. I don't have an x in each of these terms. I don't have a y in each of these terms. I don't have a z in each of these terms. Factorise it. Factorise each of the terms. So go 7z take 2 times z plus 3 times z times x plus 4 times 7 times y. Alright, over 7. Now if you look at each of these terms, each of the bits that are separated by plus or minus signs, can you see a factor that's common to both? Hopefully you can see all these 7s. Alright, so the common factor is 7, so that is going to equal 7 outside of z, take 2, and just be careful, that's an x, that's a times, it's not an x, 2 plus 3, that's an x there, that's a times there, 3x plus 4y. Alright, and that's a z, not a 2, over 7. And then of course you can cancel the 7s, so you'll get left with z take 2 plus 3x plus 4y. Okay, so that's just another way of doing it. You can just factor each of the terms and then pull out the common factor if you're struggling to see what the common factor is. But you don't have to. If you can see what the common factor is straight away, just do it from there. That's absolutely fine. Alright, one more example. I'm going to do one which has a different variable in it. So you're used to x's, let's put in a y. So xy cubed plus zy squared, and that's cubed all over y. Alright, let's factorize the top. Okay, so that's going to equal, what's common to both? Well, there's y's in both, aren't there? Y's in this one and y's in that one. So that's a z. So if I pull a y out of the front, can I pull 2 y's? Can I pull out y squared? Well, that's going to be alright, because that is 2 times y squared. So if I pull out this bit, if I pull out y squared, I'm just going to be left with 2, that's fine. What about with this one, xy cubed? If I pull out y squared, what's left? X by y, alright? I need one more y. So I need to multiply y by y squared by y to get y cubed, so I get left with xy. So that does mean that I can actually pull out y squared. And again, you could try that. If you want to, you could write it as like x times y squared times y plus 7y squared over y. I think it might just help you. So that's going to pull out y squared, and you're going to get left with xy plus z divided by y squared. Then you can just cancel the y squared, and you get left with xy plus z. So hopefully that helps, and enjoy the puzzle.